Now that we've talked about adding and subtracting polynomials, let's talk about multiplication. And to multiply, we're going to have to use our distributive property again. So let's start with some basic polynomials. A polynomial times a single number or term. In this case, 7 times negative 6x squared minus x plus 5. In this case, we need to distribute the 7. Essentially, we need to multiply everything inside the parentheses by 7. So I should have a 7 times negative 6x squared. We know that 7 times negative 6 is negative 42. We then need to multiply 7 times negative x, which would give me negative 7x, and then finally 7 times 5, which would be 35. So we were able to multiply this fairly easily. Let's do one more example before we move to something a little more complicated. Here we have negative 5x cubed times negative 4x to the 4th plus x cubed minus 7x minus 3. And the same properties are essentially going to hold. We're going to have to distribute this term out front. Multiplying the first terms, we know that negative 5 times negative 4 is positive 20. And we also know that multiplying exponents means we add the exponent. So I have an exponent of 3 on the outside and 4 on the inside, and 3 plus 4 is 7. For my next term, I would have negative 5 times 1, which is negative 5. For the x term, I have a 3 on the outside and a 3 on the inside, so 3 plus 3 is 6. The next two, negative 5 times negative 7 is positive 35. I have my x. I have an exponent of 3 on the outside and 1 on the inside, so 3 plus 1 is 4. And then finally, negative 5 times negative 3 is 15, and we only have the 1x cubed here. So we were able to multiply that. So now that we have this distributive property down and see how it works with both just numbers out front and a smaller polynomial out front, let's try to expand this to some bigger polynomials. Here we have two polynomials, and essentially we're going to do this the same way. I'm going to multiply this whole thing at the first times each term. So we'll start by multiplying it by negative 9x squared. Once we do that, we move to the next term, which is negative 3x, and then the last term, which is 7. And now that we've done that, we can use the same thing we were doing before. Negative 9 times 6 is negative 54. I have an x squared on the outside and 1 on the inside. We know 2 plus 1 is 3. We also have a negative 9 times negative 7, which would be positive 63, x squared. We then move to our next parenthesis. Negative 3 times 6 is negative 18. And then I have two x's here, so x squared. 1 on the outside, 1 on the inside. Negative 3 times negative 7 would be positive 21, and we have a single x here. The last parenthesis, 7 times 6x. We know that 7 times 6 is 42, so 42x. Then 7 times negative 7 is negative 49. From there, we can just combine like terms. We can see that our x cubed term is unique. There's only one x cubed term, so now let's look at x squared. We see that we have two of them, a 63 and a minus 18. So 63 minus 18 is 45, so we have a 45x squared. Next, we'll look at the x terms. We see that we have a 21x and a 42x, and we know that 21 plus 42 is 63. And then finally, we look at our last term. We see the constant of negative 49, and there's no other constant, so we now have our answer. And this was a very long process, and we can shorten it. We don't want to have to write out each one of these steps every time. So let's try another example where we use another method to essentially do this exact same process. Here is a problem very similar to the last one, and like I said, we don't want to have to write out all of those steps, but we still do want to get the answer. And the idea is we're going to multiply everything in the first parenthesis by everything in the last parenthesis. So we're going to start term by term. I'm going to start with this negative x. and distribute it to the second parenthesis. So negative x times negative 5x squared, or negative x times 5x squared would be negative 5x cubed. I have a negative x times negative 3x, which would be plus 3x squared. And then negative x times negative 1 is plus x. We then do the exact same thing with the second term in the first parenthesis, the negative 1. Negative 1 times 5x squared would be negative 5x squared. Negative 1 times negative 3x is plus 3x. And then negative 1 times negative 1 is plus 1. So this was a lot less work, and now we can just combine like terms. You'll notice I have an x cubed in only one of those, and next we go to the x squareds. I have a 3x squared and a negative 5x squared. So 3 plus negative 5 is negative 2x squared. Next we go to our x terms. I have a 1x and a 3x, which would give me a total of 4x, and then finally I have the last constant term, which is just plus 1. So we did a lot less work and have our answer. Let's do one more. This one looks a little bit easier because our second parenthesis no longer has 3 different things, instead it has 2. But we can still do the same process. We do the negative 5x times x, which would be negative 5x squared. And immediately whenever you see this problem, you may remember FOIL. And that F stands for first, multiplying the first 2 terms, which is exactly what we just did. The next thing in our process was to multiply negative 5x times negative 2, which would be 10x. And that's the O for the outer terms. I multiplied the 2 outside terms. I've now multiplied the first thing in the first parenthesis by everything in the second parenthesis, so let's go to the next thing, the 8. 8 times x is 8x. That's the I for inner. And then I have 8 times negative 2, which would be negative 16, which is the L for last. We can then see that we have a 10x and an 8x, which adds to give us 18x. And we have our answer. So essentially, this process is the exact same thing that we learn as FOIL.